In this lesson, you will learn to define tangent, sine, and cosine ratios for a right triangle. Now, before we get into the ratios, we first need to learn the parts of a triangle. So using angle A, by the way, we're assuming this is a right triangle. Using angle A, the hypotenuse is across from the right angle. So we've learned that before, and the hypotenuse in this case would be 5. And now using angle A, the opposite side, so looking at angle A, the opposite side would be across from angle A. So over here, across would be 4. So the length of the opposite side of angle A would be 4. And then the other side that is not the hypotenuse, but it's next to angle A, is what we call the adjacent side. So the adjacent side is with a length of 3. Now, using the same picture, but now looking at angle C, we want to identify the hypotenuse, the opposite side, and the adjacent side. Well, the hypotenuse is always across from the right angle, so it's still going to be 5. But then now for the opposite side, opposite is going to be across from angle C. So the opposite side of angle C would be with a length of 3. And then the other side, the adjacent, is a length of 4. And adjacent means next to, by the way. So the side that is next to angle C, but is not the hypotenuse, would have a length of 4. Now with right triangles, we have different ratios that we are concerned with. And we call these trig or trigonometric ratios. Trig refers to triangles. So we have ratios with triangles. And so the trig ratios that we have, first one is sine. Sine is opposite over hypotenuse. And then cosine is a ratio of the adjacent side over the hypotenuse. And tangent is a ratio of the opposite side over the adjacent side. So some abbreviations we have for sine, we just have SIN. Cosine would be COS, and tangent would be abbreviated with TAN. A mnemonic, or a way that you can remember this, is if you were to take sine and opposite over hypotenuse using the first letter of each of those words. So sine, opposite, hypotenuse. And then cosine, we have a C, A, and H, the first letter of each of those words. And then tangent, the first letter of those words, and you were to write them out. So for S, we have OH. For cosine, we have CAH. And tangent, we have TOA. If you put this together, we have the mnemonic of SOHCAHTOA. So it may be kind of a weird way to remember that sine is opposite over hypotenuse, and then cosine and tangent are the other ones, but it might be helpful for you to remember. And if you want one step further, if you took each of those letters and make a word that corresponds with it to help you remember SOHCAHTOA, you could take the SOH, CAH, and TOA to come up with the phrase, some old hippie caught another hippie tripping on acid. Both are kind of weird ways to remember, but hopefully one of these will help you remember the different trig ratios. Now, using the trig ratios by looking at an angle. Say we had angle A, and we're using this one to determine what is sine, cosine, and tangent of angle A. Well, sine, cosine, and tangent, we have the ratios listed. And then using angle A, we said the opposite of angle A is across from the angle. So over here would be opposite. Hypotenuse is across from the right angle, which would be over here. And then the adjacent would be the other one. So what I can say is that sine of angle A would be opposite over hypotenuse, which would equal 4 over 5. Because opposite has a length of 4, and hypotenuse has a length of 5. And then cosine of angle A would equal adjacent over hypotenuse, which would be 3 over 5. And then tangent of angle A would be opposite over adjacent, which would be 4 over 3. Now looking at angle C, using the same trig ratios, angle B is our right angle, so 5 would still be our hypotenuse. The opposite side would be across from angle C, so 3 would be the length of the opposite side, and the adjacent side has a length of 4. So the sine of angle C would be opposite over hypotenuse, which would be 3 over 5. Cosine of angle C is adjacent over hypotenuse, which would be 4 over 5. And then tangent of angle C would be opposite over adjacent, which would be 3 over 4. So now that we know opposite, adjacent, hypotenuse, plus the 3 trig ratios, we can use that information to solve using those trig ratios. So our objective here is to solve for x. Now we can use either the 32-degree angle or the 58-degree angle. But if we were to use the 32-degree angle, then the opposite side would be x, and then 22 would be adjacent. So the question is, which trig ratio uses opposite and adjacent? Well, that's going to be your tan ratio. Tangent would include opposite and adjacent. Tangent, by definition, is opposite over adjacent. So if I take tan of this angle, tan of 32 degrees, that equals opposite, which is x, over adjacent, which is 22. Now for these problems, you're going to need to use your calculator, because your calculator has a button that will find the tan or sine or cosine of any angle. So on your calculator, find the tan button, and then type in 32 and press enter, and you'll be getting 0.6249 for the tan of 32 degrees. If you're not getting 0.6249, check to make sure that your calculator is in degree mode, not radian mode. So you'll notice on your calculator, it might say DEG for degree, or it would say RAD for radian. And if it says RAD, you're in the wrong mode. So figure out how to change that into degree mode. But once you have 0.6249 for tan of 32, then you can solve for x by multiplying both sides by 22. When I multiply both sides by 22, the 22's will cancel over here. I'm left with x equals, and then 22 times 0.6249 would give you 13.75. Now, like I said, we can use either the 32-degree angle or the 58-degree angle. So using the 58-degree angle, we would find that we would get the same solution. So using the 58-degree angle, the opposite of 58 degrees would be the 22, and then x would be your adjacent. So then using opposite and adjacent, we once again are going to use the tangent ratio. So we say the tangent of that angle of 58 degrees equals opposite over adjacent, which is 22 over x. So then in your calculator, type in tan of 58 degrees. When you do that, you're going to get 1.600 for that answer. And then from here we can solve for x. To solve for x, we can think of this as cross multiplying, where this is over 1, and you have 1.60 times x equals 22 times 1. So then from here we can solve for x by dividing both sides by 1.6, and on the left we'll get this to cancel, and then we're left with x equals 22 divided by 1.6, which would equal 13.75. Now from here I'm going to walk you through 2 more examples like this, and then we're going to walk you through 3 examples after the fact where we have to find the missing angle. So the next example, we have this picture given to us, and our objective is to solve for x. Now we can use any angle, but if we were to decide to use the 32-degree angle, what we can do is then use the fact that x is your opposite side and 22 is going to be the hypotenuse. It's across from the right angle. And with opposite and hypotenuse, we're trying to figure out which trig ratio uses opposite and hypotenuse. So if we think through, we can remember that sine equals opposite over hypotenuse. So if we take the sine of 32 degrees, that equals opposite over hypotenuse, which would be x over 22. So sine of 32 equals x over 22. And on your calculator, you'll see a sine button. So press sine and then 32, and you would get 0.5299. And then from here, we can solve for x by multiplying both sides by 22. When I multiply both sides by 22, I'll now have x on the right side, and then 22 times 0.5299 on the left side. So x would equal 11.66. And once again, I could use the other angle, the 58-degree angle. And if you were to do that, 22 would still be the hypotenuse, but x now would be adjacent, not opposite. So from here, the question is, which trig ratio uses hypotenuse and adjacent? And if you think through that, we would conclude that we need to use the cosine ratio, because cosine is adjacent over hypotenuse. So we can take the cosine of 58 degrees and set that equal to adjacent over hypotenuse, which would be x over 22. And then on your calculator, you can type in cosine and then 58, and we would get 0.5299. And then from here, we can solve for x by multiplying both sides by 22. And when I do that, I now have x on the right side, 22 times 0.5299 on the left side, which would give me 11.66. So notice either way, we get the same solution. One more example, trying to find the missing side length. So we can use either angle. Let's use the 40-degree angle in this case. So using the 40-degree angle, the x would be your hypotenuse, 10 would be opposite. So which trig ratio uses opposite and hypotenuse? And you would find that sine would use opposite over hypotenuse. And so from here, we're going to use a sine ratio where sine of 40 equals opposite over hypotenuse, which is 10 over x. So sine of 40, you can put that into your calculator, and you would get 0.6428 equaling 10 over x. And then we can solve this for x by cross multiplying. So think of this as being over 1, and you can multiply 0.6428 times x, and then multiply 10 times 1 to get 0.6248x equaling 10. And then to solve for x, I can divide both sides by 0.6248. And then I would get x on the left side, and then 10 divided by 0.6248 on the right side, which would equal 16.01. Now if you were to use the 50-degree angle, then x would still be your hypotenuse, but 10 would now be adjacent. So the trig ratio that uses hypotenuse and adjacent is cosine. Cosine is adjacent over hypotenuse. So we can say the cosine of 50 degrees equals adjacent over hypotenuse, which is 10 over x. And then your calculator can do cosine of 50. Cosine of 50 would be 0.6428, and we have the same equation that we just had, where when we solve this for x, we would once again get 16.01. So now we're going to work with trying to find missing angles. So with missing angles, it's kind of the same setup where we determine which trig ratio are we going to use by looking at the sides that are given. So we know that using angle x right here, that 5 would be your hypotenuse, and then 2 is adjacent. So then the question is, which trig ratio uses adjacent and hypotenuse? And that's going to be cosine. Cosine is adjacent over hypotenuse. So I can say that the cosine of x degrees equals adjacent over hypotenuse, which is 2 over 5. So from here, we're actually done with the solving. We just need to know how to use your calculator to get the correct answer. So your calculator, if you were to type in cosine of 2/5, what it's saying is that 2/5 is your angle. But in this case, 2/5 is not your angle. So we need to type in something a little different so your calculator knows that 2/5 is not the angle, but it's the ratio of the angle. So what you do is on your calculator, you see that we have a cosine with a little -1 above it. And this is typically a second function on your calculator. So press second or a shift button and then press cosine to get this notation. And then from there, put in the 2/5. So your calculator will see this, and the -1 means inverse cosine. So it's going to see this notation and realize that 2/5 is your ratio and not your angle. So the answer it's going to give back to you would be 66.42 degrees. And that would be your solution. Here's another example where you're trying to find x once again, but in this case, 5 would be across from angle x, so 5 would be opposite, and then 2 would be your adjacent side. So the question is, which trig ratio uses opposite and adjacent? And that's going to be your tangent ratio. Tangent uses opposite over adjacent. So I can say the tangent of angle x equals opposite over adjacent, which is 5/2. So then from here, all we do is we plug into our calculator. So we push the inverse tan button, so tan with a little -1 above it, and then type in 5/2. And your calculator will see this and realize that 5/2 is your ratio because you pushed in the inverse tan button. And then the answer that it's going to give back to you will be your angle measure. So the angle measure of x would be 68.2 degrees. Here's one more example where we're trying to find x. And in this example, 35 would be your hypotenuse. It's across from the right angle. And x would be opposite, or 10 is opposite of x. So opposite is 10, hypotenuse is 35. Which trig ratio uses opposite and hypotenuse? Well, that is going to be your sine ratio. Sine is opposite over hypotenuse. So we can say that sine of angle x would equal opposite over hypotenuse, which is 10/35. So on your calculator, you can push the inverse sine button and then push 10/35. And your calculator will see the 10/35 and realize that is your ratio. And the answer it's going to give back will be the angle measure. And when you push this in, you would get 16.6 degrees as your solution. And that concludes our lesson for today. We will see you next time.